This question is about atomic structure. There is a general increase in first ionisation energies across period 2. So that's lithium to neon. Give one example of an element that deviates from this trend. So these are the two little blips that we've got in there. And explain why. So we can either have boron, because that's the one in group 3, or we can have oxygen. So let's do an explanation for each of those depending on what you've got. So boron, remember, this is where the electron is being removed from the 2p subshell, which is higher in energy, therefore less energy required. Of course, this is comparing to the 2s. And then with oxygen, so this is the first element where an electron is being removed. That is paired in the 2p orbital. Therefore, we get repulsion. So, 1 mark for boron, 1 mark for it going from a new subshell, 1 mark for it being higher in energy. And if you've done oxygen, so 1 mark for oxygen. First one for saying that it is the first one that is being paired in the 2p orbital, and then the third mark for stating that we have repulsion. Part B, give an equation including state symbols to represent the third ionisation energy of aluminium. So the second has already happened. State symbols, remember these have to be in the gaseous state. And again, I've written myself a little reminder over here. And then C, the data in table 2 shows the successive ionisation energies for an element in period 3. So that is sodium to argon. Identify the element and explain your choice. So good tip here is to count up to the nearest 500. So we've got 800, 1500, 1500, 3000, 4500, and then 16,000. So I think you can see there that we've got a big jump after the fourth electron. So it's in group 4 of period 3, which means the element is going to be silicon for 1 mark. So big jump in ionisation energies between 4 and 5 for the second mark, which is electrons or electron being removed from an inner shell or a shell that is closer to the nucleus for the final mark.